Welcome to this session. This session, we are going to do a problem to determine whether the set of vectors in P2, that is set of all polynomials of degree less than or equals to 2, is linearly independent or linearly dependent. So the problem reads, determine whether the set of vectors in P2 is linearly dependent or linearly independent. Where this is a set, we have 1 plus x minus 2x squared, 2 plus 5x minus x squared, and then x plus x squared. So to solve this, we start from definition of linear dependence and linear independence. So solution. Now we can call this one our V1. This first polynomial, call this one V2, call this one V3. So the set S2 is linearly dependent or linearly independent if the vector equation C1, okay, this is how I'm to start to test. So to test, whether S2 is linearly dependent or linearly independent, we solve the vector equation C1 V1 plus C2 V2 plus C3 V3 equals to 0. And if there are two cases, one, C1 equals to C2 equals to C3 equals to 0, then S2 is linearly independent. And number two, at least C1 or C2 or C3 is non-zero, then S2 is linearly dependent. So let's write the vector equation. So C1, and then V2 is the first, V1 is the first matrix, first polynomial given by 1 plus x minus 2x squared, and then plus C2, V2 the second polynomial, which is 2 plus 5x minus x squared, plus C3, V3 the next polynomial, which is x plus x squared, should give us, now 0 polynomial for in P2 is given by 0 plus 0x plus 0x squared. This is how we write a 0 polynomial in P2. Now let's open this. We'll have C1 plus C1x minus 2C1x squared plus 2C1, 2C2 plus 5C2x minus C2x squared plus, actually I can write this one 0 C3 plus C3x plus C3x squared equals to 0 plus 0x plus 0x squared. So I've written this one as 0x C3 so that I have all the polynomials expressed in the standard form a plus bx plus b plus c squared. So here I add constants, so the c1 plus 2c2 plus 0c3, and then I add those terms with x, so c1 plus 5c2, and then plus c3 times x, and then plus those terms with x squared is minus 2c1 minus c2 plus c3 x squared. This would give me 0 plus 0x plus 0 x squared. Now for this equality to make sense, then the constant term to the left should be the same as constant term to the right. Coefficient of x to the left should be the same as coefficient of x to the right. Coefficient of x squared to the left should be the same as coefficient of x squared to the right. So this will be c1 plus 2c2 plus 0c3 should give us this constant 0, and then c1 plus 5c2 plus c3 should give us coefficient of x to the right, which is 0, and minus 2c1 minus c2 plus c3 should give me 0, which is coefficient of x squared on the right. So let's call this one system 1. So now the question reduces to just solving system 1, which is a homogeneous system of 3 linear equations in 3 unknowns. So to solve this one, we use Gaussian elimination. So write the matrix, augmented matrix of this system, which is 1, 2, 0, 0, 1, 5, 1, 0, minus 2, minus 1, 1, 0. So this is what we have. Then, so this is what we call the augmented matrix. Now we solve this augmented matrix. So we write it 1, 2, 0, 1, 5, 1, 0, and then we have minus 2, minus 1, 1, 0. So I say row 1 to be row 1, row 2, I'll say row 2 minus row 1, and then row 3 will be row 3 plus twice row 1. Because I need this position to be 0, this also to be 0. Now this will give me 1, 2, 0, 0, 0. Now 5 minus 2 is 3. 1 minus 0 is 1, 0. And then minus 1 plus 2 times 2, which is 3. 1 plus 2 times 0 is 1, and then 0. So this row 1, can say row 1 to be row 1, row 2 to be row 2, and then row 3 to be row 3 minus row 2. So that I'll have 1, 2, 0, 0, 0, 3, 1, 0, 0, 0, 0, 0. And then next step, I say row 1 to be row 1, row 2 to be row 2 times a third, so that I ensure that the leading element is 1. So I say a third, row 2, row 3 remains to be row 3. So by doing that, I'll have 1, 2, 0, 0, 0, 1, a third, 0, 0, 0, 0, 0. So this is 1, this is 1. Remember, this corresponds to C1, this C2, this C3. So it means that C3 is a free variable. So from this one, we have the system C1 plus 2C2 equals to 0, and C2 plus a third C3 equals to 0. Now this means C3 is a free variable, so it can take on any value. Therefore, let C3 to be t, where t is any parameter, real parameter. So that implies that from equation 2, if I call this one 1, this one, I call this one 2, call this one 3. From 3, we have C2 equals to minus a third C3, which is the same as minus a third t. So C2 is minus 1 over 3 t. And then from equation 2, from 2, C1 equals to minus 2 C2. And because I have the value of C2, then I can get C1. So C1 will be minus 2 times minus 3 over 3, minus 1 over 3 t, which will be 2 over 3 t. So the solution set will be C1 equals to 2 over 3 t. C2 will be negative a third t, and then C3 is given by t. So this is a solution set where t is any real number. Now in this case, we can fix t to be any real number to get a specific solution. So setting, so to do away with fractions, I can say setting t to be 3, then C1 will be 2 over 3 times 3, which will be 2. C2 will be negative a third times 3, which is negative 1. And then we have C3 to be 3 itself because the value of t is 3. So C3 equals to 3. So therefore, we have V1 is 2 V1, C2 is minus 1, so minus V2 plus 3 V3 equals to 0 vector. So i.e. S2 is linearly dependent because all the values of the Ci's are non-zero. So that's what we have. I remember when you're determining this value here, so remember t can be any value. So fix t can take on any real number. So just to be specific so that now you don't confuse who that t is r star, so that you don't say that now when I put 0, then I'll have the C1, C2, C3 being 0. So C star, where star means we are excluding 0 value. So therefore the given set is linearly dependent. Just one of the things that you need to note when you're solving such kind of problems, when you get that once you have reduced your augmented matrix, you result into a case whereby you have one variable being free, then it automatically tells you that the system you're solving has an infinite number of solutions. Therefore, if you're dealing with the cases of linear combination or linear dependence, then the vectors involved are linearly dependent, or we can express one vector in terms of other vectors. That's one vector is a linear combination of the other many vectors. So that should be clear. Saying C1 2 over 3t minus a third t and C3t. When you fix t for 0, so that will give us a case where you're saying C1, C2, C3, 0. So to ensure that now you don't have that confusion, ensure that you pick t so that it is a member of R star. R star means you take all the real numbers excluding 0, because that will bring confusion. Or to make your work easier, immediately you have found that the system you're dealing with is resulting into a case of infinite many solution, then know that the vectors involved are linearly dependent, or one vector can be expressed as a linear combination of other vectors. That should be clear. Thank you.